what I want to do now is to talk a little bit about a use case of MAPD that I've used in my own research at a startup company that, as was mentioned, I work with called Cambridge Mobile Telematics. So CMT, or Cambridge Mobile Telematics, builds mobile apps to help measure driver performance. This is as in car drivers. And the way that it does this is we essentially use the sensors on modern smartphones to detect unsafe driving, things like phone use while driving, or whether somebody was harsh braking, accelerating, or having excessive speed, so on and so forth. So this apps that this company builds are deployed on many tens of thousands of smartphones around the world, and there's a real opportunity that we have with this data to turn it into insight. Like, can we understand the driving of an individual driver and whether they're driving in a risky way, or whether drivers in one region are riskier than drivers in some other region? Can we correlate those risk factors like harsh braking or phone use while driving with claims and accidents in a given region by working with insurance companies or government organizations that might have access to this kind of data? And then finally, can we look at some road or a neighborhood or something very granular and understand what kinds of risky behaviors are happening on top of it? So MAPD has actually allowed us to answer a bunch of these questions, and I think it's pretty cool. So I'm just going to show you a quick demonstration of it. This is a small sample data set from this company, CMT. It represents about 63 million trips, 1 billion kilometers of driving in the United States. We also analyzed a slightly different subset of it that is events like these harsh braking events or people using their phone from 2 days of driving in the United States. And what we wanted to do was to understand how driving behavior varies by region, both on a sort of national scale, and then also show you a little demonstration of some data from Boston. So what we're looking at here is just a map of the United States. So each little dot that you see on this map represents a single one of these 60 million trips that we're looking at. And you can see that when we're zoomed out at the scale of the United States, there's some numbers across the top that show the star rating and braking rating. So the star rating is like you get a score from 1 to 5 for every trip. So the average star rating is 3.82, but you can see how these subscores like braking or using your phone vary in these regions. So now you can use MAPD to zoom in on a region. So with MAPD, I type Boston, and the visualization, takes me in and zooms me right into Boston. And I can see, how the score varies in Boston. So the average score in Boston was 378. I can zoom out and look at New York, and then the average score is, 363. So I like this because it shows that Boston drivers are better than New York drivers. And then we can zoom into Chicago and see how that region varies. And then if we want, we can, zoom all the way out to the scale of the entire United States again. So the nice thing about this dashboard is that we were able to build this up in just a few minutes with MAPD. It's really a drag and drop interface for putting this together and visualizing it. So I want to show you one other example data set here. So this is a slightly different data set. Again, these are the events data, and you can see how the events vary in this data set of about 6 million events. Many of the events are speeding, slightly fewer number of them are phone usage, and so on and so forth. And we plotted each one of these events now on a map, and each dot is color-coded by the type of event. And then we have a time plot that shows us how the events vary over time. So what we can do now is zoom in on a particular region. So what we're going to do is zoom in on Boston, and I'll show you what some of the driving behavior looks like in Boston. And again, this is a MAPD visualization that we were able to produce in just a couple of minutes so that you can very quickly get a sense of what this data looks like. And this is, an example of a real-time usage of this tool. So the first thing we're going to do is look at how driving behavior varies by time of day. So I highlight a region here, in this case in the middle of the night, and you can see that in the middle of the night, most of the behavior is speeding, these events that are occurring. But as I slide this thing forward, what you'll see is that the events become more and more, a higher and higher prevalence of events like phone usage. So this is in the middle of the day, people are driving along, they're stuck in traffic, they got late for their meeting, they're making phone calls as they drive around on the roads. And this is important for our business at Cambridge Mobile Telematics because it lets us understand the riskiest times of day, under the belief that phone usage is in fact, the thing that's most highly correlated with distracted driving. So I'll just show you one more thing here just to show you the kind of very fine-grained analytics we can do with MAPD. We're going to zoom in on a single road segment here. This is the Longfellow Bridge that connects Cambridge to Boston. This particular bridge happens to be under construction. And so, first of all, there's only traffic in one direction, which you can clearly see by these green dots that are spread across one side of the bridge. And these green dots, they actually represent phone usage. So these are places where people are sitting in traffic talking on their phone. You can see that most of the events in this region are smartphone usage. You can click on one of the events and see it. And so what this shows you is that basically this bridge is a parking lot. I happen to know this, but this is an analysis that we can get out of this kind of a system. You can see that people aren't speeding here. They're not slamming on their brakes. They're just moving very slowly, and they're bored, and they're stuck in traffic. Okay, and we can do this kind of analysis for other regions of the city as well by, for example, zooming in on a freeway segment over here. This is Storrow Drive, which is a segment that people speed on. The speed limit's low, but people like to drive fast. And you can see other kinds of regions as well, like regions with lots of these blue and yellow dots that represent places where people are slamming on their brakes or accelerating very quickly. So what this has allowed us to do as sort of a bottom line in Cambridge Mobile Telematics is do this kind of very granular analysis of how driving varies across different regions. So we can, identify that Billings, Montana, for example, is the place where people are safest in driving. And that's probably because there's not a lot of traffic and they're just trying to get from one place to the other and they're not stressed out and they're not slamming on their brakes and so on and so forth. Odessa, Texas is the worst place, which is kind of interesting. Jersey City, New Jersey is the overall, place where the most dangerous driving. There's almost 25 minutes of speeding per 100 miles. So MAPD has enabled us to do this very granular kind of data analytics. So in conclusion, I just want to say, I think interactive analytics is a real new frontier, and I think MAPD is a leader at the front of this. There's a huge performance gulf between what existing data processing systems can do, whether they're, cloud-based systems, whether it's next-generation NoSQL systems or, these Hadoop and Spark-like systems, and what people really want to do, even on simple tasks, which I think involves this kind of very interactive analytics. And so, I think what we're going to see as we go forward is that as the analytics that people want to do gets more and more sophisticated, this gap is only going to grow and get worse.